Hello everyone. In today's session I'll take you through another concept of time and work which is based upon proportionality. Okay? So there are few terms in time and work which is nothing but men, days, work. Okay? So if I talk about men and days, more the number of men and more the number of days, the work done by them will be more. But in case men remain intact and days reduces, then the work will also reduce. And if days remains intact and men reduces, then work will also reduce. That means we can directly interpret that men and days are inversely proportional. Similarly, the another term that I can introduce, and this is rate. Rate is nothing but effort put per day or number of hours work done, number of hours per day kind of a thing. So if the rate per day is more, work will be more. If the rate per day is less, work will be less. Rate per day by these men are more, then the work will be more. That means men and rate will also be inversely proportional. But more the men, more the work. More the rate, more the work. More the days for which they are working, more will be the work. That means men will be directly proportional to work, rate will be directly proportional to work, days will be directly proportional to work, but among themselves, rate, men and work will be inversely proportional. So I can also put it this way, that M into R into D is equal to W, because among themselves they are inversely proportional. If I remove this proportionality sign, I can also say that this is nothing but equal to, I introduce a variable K. So K will be equal to M R, D is nothing but number of days divided by work. So this will help us in solving a lot of questions on time and work. Right? So let me take a small example. Let's say that the question is, there are few men and they are working for a few days. I'll give the numbers later on. And there's another term called rate, and then there's a work which they are doing. Let's say 100 men working for 50 days at the rate of 12 hours per day can complete some piece of work. We can assume this to be, let's say, 100 or 1000 units. So the question, it is given that 100 men, when they are working for 50 days at the rate of 12 hours per day, they are able to complete 100,000 units of the work. How many men working for, let's say, 80 days at the rate of 8 hours per day would be able to complete 1500 units of the work? Is the question. Right? There will be language in which you will be given this question. I am only writing the numbers and then you are supposed to find this. So there are different ways. If I directly apply this to something that I have already learned, I know that we know that men, day and rate upon work, if I put it M1 D1 R1 divided by W1 is equal to M2 D2 R2 upon W2. The easiest approach is a plug and play kind of a thing where you can directly put the values. The only unknown in this case is nothing but M2. So if you put these values and solve this, you will be able to get your answer. So it is going to be 100 into 50 into 12 divided by 1000 is equal to M2, which is unknown in our case, into 80 into 8 divided by 1500. You solve this and you get your answer. Right? But in case you want to do it with proportionality, wherein it involves a lot of logic also, then again it can be done. Right? Let's say that the unknown factor is x. So what you can do, you can write this as x is equal to, or x by 100 is equal to the remaining things. Fine. Now I need to compare each one of them, that means days, rate and work independently with men. So if I compare men with days, right? Initially they were working for 80 days, now they are working for, so initially they were working for 50 days, now they are working for 80 days. Now as they are working for more days, So the men required will be less. So out of 50 by 80 and 80 by 50, the lesser quantity is 50 by 80. I'll explain it again. Let's say if I compare men with rate. Initially they were working for 12 hours per day, now they are working for 8 hours per day. So the effort put by them is less as compared to what they were putting earlier. So if the effort is less, more men will be required. So the more quantity is nothing but 12 by 8. Similarly, I compare men with work. Initially they were supposed to do 1000 units of the work, now they are supposed to do 1500 units of the work. So that means the work required to be done is more. So the men required will also be more. So the more quantity in this case is nothing but 1500 divided by 1000. You solve this and you will get the value of x, which is nothing but this quantity. So either of the two approaches will help you to solve this question with minimum ease. So that is how you are supposed to approach these kind of questions. Thank you.